Hey everybody, thank you. I could quickly get into this topic. Uh, so now that the second topic, once again, we're gonna only decide on what is very important for us to know and understand from performance prediction aspect, and we're gonna really focus on how do you get the performance prediction done on a real time, so that from a examination point of view as well as from a very realistic point of view of managing or at some point of time performing it by ourselves, we can do it out. I can also have a separate video made on top on this after this rather, where I gonna actually tell you like show you in real time how this performance prediction can be done. Right. So let us get started with performance prediction for HPC on cloud, and let us see how we're gonna go forward and do it out. Now, just to start up with the first point, we have one new word here, what we call HPC, stands for high performance compute. Now, don't get misunderstand on that. This C does not stand for cloud. This stands for compute or computing at some point of time. Right. Now, the first question is like, what is the relation between HPC and cloud? Now, HPC is a mechanism, and if at all I have to achieve this mechanism, I have to deploy the complete application or my infrastructure on cloud to achieve high performance computing. Now, how does a high performance computing or a performance prediction for HPC supposed to be done on cloud? Or what is the, first of all, what is the requirement for performance prediction? The moment we call performance on or off any application or a platform, or at the max to of an infrastructure, we have to have some sort of a benchmarks defined. Okay. Now, what is a benchmark, or first of all, what is a performance in terms of that? If I am talking about an application, I'll be really deciding upon what, how many customers I can accommodate at a specific point of a time. If at all I am talking about a platform, what are my mean response time? If at all I'm talking about an infrastructure, I can also talk about the cost, or what is the least amount of cost I can provide the complete infrastructure and all. So those all components will be coming under performance. Now the thing is that for every performance, we're gonna have something called benchmark. What is a benchmark, you ask? Benchmark is nothing but a set standard. So if at all I have to define something, but if I have to call, yes, I gonna measure my performance of an application in terms of response speed, I gonna say I can have one user getting connected to this application and completing the complete task execution in 3 seconds, then I'll be calling the minimum 3 seconds is my benchmark. Right? So that is how the benchmark component is actually been decided, demonstrated. Right. Now, how do I predict the performance, and why this prediction of performance is so important? The basic idea is, when I have an application and I wanted to deploy that applications on cloud computing environment, it is very obvious to understand that there are two components which are very crucial for this deployment. One is the cost aspect. Second is the performance aspect. Now, once again, this performance aspect, it can be considered as in terms of speed, and the cost aspect can be considered in terms of how much money the client actually has to pay to the data center owner to deploy this application and have it running. Now, it is also quite obvious to understand that if at all I want a very high performance, my cost will keep on increasing. And if I have to settle down for a specific low set of performance, I can have a moderate set of cost or a low cost adjustments. Now it is always expected to go ahead and deploy that, whether whatever the performance I'm expecting, for that what is the infrastructure uh, requirement is required, and for that what is the actual cost approximation supposed to be there. So based on my performance, I can decide how much infrastructure I need, and based on that I can have a prediction on the cost. So that is how the performance prediction is very, very important. So how is actually gonna happen? So once again, I'm gonna take these applications, I'm gonna configure multiple virtual machines. For every specific virtual machine, I'm gonna go ahead and decide how much of CPU is allocated to the virtual machine, how much RAM is actually allocated to the virtual machine, how much memory, or I should say how much storage rather, is assigned to that, and what is the network bandwidth is allocated to this virtual machines. Now, if at all I say I'll be having 2.4 gigahertz processors connected to that, and I'm gonna have a 4 core of that, so I'll be having some X amount of costing associated to that. If I also decide that I'm gonna have 2 terabytes of RAM assigned to that virtual machine, and so for that I'm gonna have Y amount of costing for that. If I also decide that I'm gonna have 200 terabytes of storage, then for that I'm gonna have some Z amount of costing. So similarly, for a network bandwidth, we know, as many of you use some specific internet service provider in your home, and then you know, based on the bandwidth, based on the network speed, they actually charge you. So for that, I can also say I'm gonna have a costing of $W for in total. Now, if at all I have one single virtual machines, I'm gonna have X plus Y plus Z plus W dollar of costing, and understand that this is for only one virtual machine. So now, based on my requirement, how much performance I want, I'm gonna have that many number of virtual machines running. So if at all I need, if this kind of costing is turning into say $100, then and if at all I'll be needing 20 virtual machines to accommodate my requirement, so it is obvious to understand 20 into $100, and that will turn into $2,000 of total costing. And that is, maybe I have decided on 20 virtual machines based on 100 users. And if at all at some point of time I see like my number of users is gonna be 10,000, and critically speaking, I'll be needing that many number of virtual machines to support that. So if at all I follow this ratio, then I'll be needing some say 200 virtual machines, and then each virtual machine is again costing me $100, and then I can always go forward and be ready to put in that much of money, that amount of money, to decide how much money is actually required for me to run this applications on a cloud data center. Now, might not be very, very important, the next part, what I'm gonna say right now for you, but whenever you go for an interview or you take up a real job on a cloud data center, there will be two things which will be very, very crucial, and you will be hearing more than your name in the industry, these two terms. One is OPEX and one is INEX. The OPEX is something like, or this is called the CAPEX also, you can say. Now, rather I'll start with the CAPEX first, or the INEX first. The CAPEX is called the capacity expenditure. Capacity expenditure is something which is your setup cost. So initially, how much money you have to pay to build these applications, or to set up your office, or hire some employees or something. OPEX is something which is called operational costing. The operational cost is something like how much money is required to run these applications on a day-to-day basis. So this application X, this component X is nothing but your operational cost, or OPEX. All right, so this is how a performance prediction is supposed to be done, and this is how the performance prediction is very, very crucial and important for us. That will be all for a time being. Hope you understood what is performance prediction and how performance prediction is important on high performance computing for a cloud computing environment. Have a nice time. Don't forget to subscribe to this channel. Thank you very much.